Okay, so as we continue our test review, we're going to go into our integrals, and we'll start right here with this integral right here. The integral of 3 times x, 8x minus 1 times e to the 4x squared minus x dx. So one of the tricks in this test is that we're getting a lot of tools of how to take integrals. Luckily, this one's really easy to identify. It's not a pattern we recognize right away, but we know that e to this has got to go. So we've got to have u equal that exponent there, 4x squared minus x. Our du is 8x minus 1 dx. And luckily there, that's a very simple substitution. That 3 remains, so we have 3 on the outside times the integral of e to the u du. So we've done our substitution. We integrate. Don't forget to integrate, even though this is super easy integral. You must integrate. Okay, and then of course don't forget your plus c. That u we substitute back in our expression. We get e to the 4x squared minus x, and then the plus c. So not too bad, but make sure that you show the integration, that you actually integrate, you do the substitution, and you get your plus c. So like I said before, we're starting to get a lot of things, and we see this, we see something squared and a 4, we're like, oh, that might be the inverse trig, but inverse trig didn't have a variable on top. So we're going to use our basic, we have no other inside function other than our denominator, so we're going to use our u and let that be our denominator. Think that maybe this is natural log. We just have to play with it and see what happens. We get du equals 10x dx. Well, that's close, except for we have a 3 and a 10 here. So let's pull the 3 out front. Then we can multiply by 10 on the inside and divide by 10 on the outside. So we have the 3 from the inside, a 1/10 from making the substitution work, and that leaves us with 1 on top because the 10 and the x and the dx become du here. So this, and this all combine to make du. So we have du there. The denominator is what we used for u. So it is natural log. So we get 3/10 natural logs of the absolute value. Don't forget the absolute value there, plus c. So this was not a hard problem, but lots of little things to remember. All right, moving on. Integral of 1 over the square root of 1 minus x squared dx. We can see that is inverse sine right away. Nothing fancy, but let's go ahead and go through the steps. A squared would be 1, so a is 1. Nothing crazy there. U squared would be x squared, so u equals x. Du equals dx. So everything works just exactly like we'd like. Sine inverse, or inverse sine, is u over a, close parentheses, plus c. Substitute our values back in, we just get the inverse sine of x plus c, and we're good. If you want to go straight there because you recognize that's the basic form, you may. All right, here we go on this one. We look here, nothing seems to ring a bell. We can't do a u substitution for natural log because we would end up with a linear function on the top that we would have to substitute. There's no other inside function. So the only other tool we have is, hopefully this is a perfect square plus a constant, so that it can be inverse tangent. But first, we already know we don't like a number in front of x squared when we do this, but we see everything's even, so we can factor out a 1/2. So let's do that first right away. See if that gives us prettier numbers. We get minus 6x plus 13. Ooh, 13 is not pretty, but let's just keep working with it. Let's complete our square. X squared minus 16, or no, 6. Yeah, just 6. Complete the square. Plus 13. We're going to group the first two. So we get x squared minus 6 plus something with a plus 13 there. We're going to half this to get minus 3, and then square it. We get plus 9. So we add a 9, we're going to subtract 9. So this becomes 4. When we factor, we get x minus 3 squared plus 4. So this does work out to be the form for inverse tangent. So writing it pretty over here, we have 1/2 times the integral of 1 over x minus 3 squared plus 4 dx. Start making our substitutions. We see that a is 4, or a squared is 4, so a is 2. X squared is x minus 3 squared, so x is u is x minus 3 squared, so u is x minus 3, so du is dx, so that makes substitution simple. So we have 1/2 the integral of 1 over u squared plus a squared du. So we integrate, we get 1/2 times 1 over a inverse tangent of u over a plus c. So 1/2 times 1 over 2 inverse tangent of x minus 3 over 2 plus c. So you get 1/4 inverse tangent of x minus 3 over 2 plus c. Hope that was clear. What I wrote was good, except for this got a little messy there. That's u squared equals x minus 3 quantity squared. Okay, and then our last one for this looks like either inverse secant or inverse sine. We would need to complete the square to figure out which one. It does have the minus there, so thinking, well, let's just finish and see what it is. So if we complete the square, show that to you. Gotta rewrite it and factor out the negative at the same time. Minus 4x. Let's see here. We have minus 4x. We're going to add something, and then we're going to subtract that something off. So we're going to take this. We get negative 2. We square it. We get 4. So we added this. So we're going to subtract it, but we added it minus 1 times. So we're going to multiply that by negative 1. So this becomes a plus 4 on the outside there. So when we factor this, we get negative x minus 2 squared plus 4. So rewriting that under the radical in here, with the minus sign in the middle, we would have 4 minus x minus 2 squared dx. Okay, that looks pretty good. So a squared is 4, a is 2, u squared is x minus 2 squared, u is x minus 2, du is dx. Get the integral of 1 over square root of a squared minus u squared du, which is inverse sine u over a plus c. So inverse sine of x minus 2 over 2 plus c. So you can write it like that. You might see it written as x over 2 minus 1, but either, like I said, either one of those is fine. I would probably write it like this, just leaving the rational function there. And we're done.